Hi, this is Lady Lex UK, and this is a Dreams gadget tutorial. Today we're going to be looking at the movement sensor. You can find that in Sensors and Input, and it's this one. It looks like a flying ball or a meteor or something. Here is the movement sensor. Now, don't forget, this is a sensor. It is not a movement gadget. This will not make things move. This just monitors that movement and gives you some data. Let's open it up and have a look. It only has 2 tweak menus, so a basic level, this is a really simple gadget. All it's going to do is provide you with some numbers. So we've got velocity, which is speed on this page, direction, and on this page, acceleration. So all of these are providing us with information. So let's go through each of these in turn. I'll start at the top. This is the sense movement button. Now, it says here, when this is wired to an object, the movement sensor will detect when the object moves. Right, there is no output socket for this, so this is not going to sense movement. So you can't use it like you can for these. What this actually is a wire that allows you to select an object. So if I was to put it onto there, the little sucker appears on the box, and now I'm going to be detecting the metrics for the movement of this object, this box. So you would wire it if you were going to be monitoring an object that was external to your gadget. So if your gadget is loose like this in the world, then you would need to wire it to something. However, there are other ways of monitoring. You can surface snap your gadget directly to the object, and now you don't need to wire it to the object because it's surface snapped to it. And you can also, and if you lift it off, you'll notice it is now connected. So we just do that again. So movement sensor, snap it to the object. Now if you move it off, you can see there's a wire, and that wire is connected into here. So that's the same thing. So you can do it manually, or you can snap it and then pull it off. Or you can put a microchip on your object, and you can stick your movement sensor inside the microchip, and it's going to know that it's connected to this object, so you don't need to wire it in that occasion either. Okay, again, if I move it out of the microchip, it knows that this is the object, and it creates a wire. Right, so once we've determined what object we are actually looking at, we then have some metrics. The top one here is velocity overall. This is the speed at which the object is moving in any direction. Up, down, left, right, it doesn't care. So that's the overall speed. This is the speed only in the X, in the Y, and the Z or Z. This provides you with a number. There are output sockets here, and that's going to send a signal with a number on it, and I'm going to show you that in a minute because I've got a movement sensor linked up to some number displayers there, and I will show you that in a second. Right, when we get down to this button, this is local space. You turn this on or off to determine whether or not you are detecting the direction locally to the object or in the entire scene. Now, I did experiment with this button, turning it on and off, and the metrics this movement sensor has provided seem to be identical. So I'm not 100% sure how this works. I'm assuming there is some subtle difference between the direction of it locally to the scene, but I can determine it by the data. So not sure how that button works or how you would use it. So there you go. This button here, relative to object, this instead of the speed being the speed relative to a standard start, This is a relative to another object. Now, I haven't done much experimentation with this, or I'm not 100% sure why you would use this, what occasion. So I haven't experimented with this. But the idea is that you would click on this and you get a dotted line here. And this is not a wire. This is a bit like the emitter. So when you choose an emitted object, it's a bit similar to that. So I'm going to say I want to know the speed of my player in relation to the speed of this object. So I've now selected that object. Now, I don't think this gadget is particularly good in that it's very difficult to see what you've done. There is no wire. You can only tell which object you've selected to be relative to by hovering over it, and it goes green and yellow like this. The only problem here is once I've selected to be relative to object, I can't deselect it. You can't turn it off. You can choose another object, but you can't unselect that one. If I try it and select it again, nothing happens. It's still linked. In fact, now it's linked twice, so I have to go back twice in order to remove it. So I think that's a problem, that you cannot remove relative to object once you've selected it. So I might issue that as a bug problem, because I think that needs to be addressed. So the speed relative to another object. So, for example, if this object and this object were both moving at the same speed, then it's going to provide you with 0 numbers. If, however, this one was moving slower than this one, then you'd get positive numbers. And if this one was moving faster than this one, you'd get negative numbers. That's how you would use it. I'm not 100% sure what game mechanic would require that information, but I'm sure there are lots of games that do. I just haven't worked out an experiment that could show it you. Right. These are the directions in the X, Y, Z. So this time we are determining, like compass directions, of the X, Y, and Z axes. Now, you can determine, because there is no north, south, east, west programmed into the world, so it doesn't know which is what. You could select which way is north. So I've decided that the X direction, when that's a 1, that's north, and the Z direction, when that's 1, that's west. That's what I've decided. And I will show you how you can use that in a minute. Right, on page 2, we have acceleration. This is not speed, this is how fast they are accelerating. So you can use a combination of these two informations, the speed and the acceleration, to do some calculations with. But otherwise it's a very, very similar number to the velocity. Right, let's have a look. Let's get rid of this one. Let's have a look at the movement sensor here that I've got wired up to all our data. So we're going to wire and select our puppet. Right there, we're on. Okay, as you can see, what I've done is I've wired all these to a switch so I can turn them on and off, but I have wired these number displayers to each of these outputs. So one displayer for each output. So we're going to see the numbers that these things are producing. Let's go into play mode and have a look. Right, okay, so the red ones are the velocity, the white ones are the acceleration, and the yellow ones are what are produced by the X, Y, Z on page 1. So let's possess our puppet and move around. So there's lots and lots of numbers. Let's concentrate on the red ones on the left. So this is our velocity, overall velocity. That's the overall speed of any of them, and you'll notice it will be the highest one in whatever direction. So if I walk slowly, you'll see it matches the Z axis at the top and the Z axis at the bottom. So I'm moving in the Z axis only. I'm not moving in the X at all. So I'm directly in a straight line on the Z axis. So if I move in the other direction, you'll see I'm moving on the X and a little bit of Z because we're not directly in line. So you see, it's the speed, it's going up and down. Now, if you look at the white ones, these are much smaller numbers. This is the acceleration speed. And again, it's in each direction. Which way are you accelerating in? Which way are you moving? So the first one is telling you which way you are moving and at what speed. And the second one is which way are you moving and at what acceleration. Now you'll notice the yellow ones, if I've just wired out from the X, Y, Z, they're just providing 1, which is no good to us whatsoever. So if you were hoping, let me just go back into this. So if you're hoping that this is going to provide you with a direction and you just wired it straight in, you're just going to get 1s. It's of no use whatsoever. What we need to do is we need to put our information into a splitter. So I've done the X. Here's the X here. I've put this into a splitter, and that's split it down into an ABC value. Those ABC values are X, Y, and Z. So let's go back into play mode. Right, now then, when we moving along, you can see these numbers are changing. In fact, I think what would be the best thing to do is if I do it in this mode. Right, I'm going to pick up my puppet. Right, and I'm going to move him around. Now when that top number hits 1, there. Right, he is now facing what I'm going to call north. That's going to be my north, 1. And if I move him a little bit, whoa, a little bit more, I should be able to get it. It's actually really difficult to get it to a 0. Oh, there. There we go. That's exactly north. He's not facing west or east in any direction. He's facing exactly north. And if I turn him all the way around, we can go to -1, and that would be south. Again, I'd have to get to there. Oh, it's difficult. There we go. That's exactly south. And if I move in this direction, we're going to get a -1 on the bottom, which is the Z. And we'll just tweak it a little bit. Like, yeah. So we'll say that is east. And that number is west. So that's how you can make yourself a compass. This information, this gives you, you notice the Y coordinate does not change because this is a 2D space, not a 3D space. It's not interested in the Y coordinate because it's just direction, and direction is just X and Z. You notice I don't need these two. I don't need all of them. I only need one of them. The X provides you with all the information I need. One is a positive number, one is a negative number, and that tells me which direction I'm facing. If I'm facing northwest, there'll be a number up here and a number down here, and that will tell you. And you can create a compass using a load of calculations to say any number between this range is him facing north, etc. And you can have some sort of display that will just put up the correct direction. So you could move things around and do all sorts of stuff. That's a nice complicated little bit of advanced coding for you. If you really fancy it, make yourself a compass. This is the way that you would use it. These are the figures that you need. Right, so that's having a look at the movement sensor. Now let's see a practical use for it, shall we? So let's turn off those because I don't need those. Let's get rid of him. And let's do show and hide. And I've got an invisible man here. Let's just turn him on. There he is. Oh, right. And let's turn this off. Right, let's go into play mode. Now, as you can see, my character is waving around like madly with his arms. That's because I haven't possessed him. I have put in an animation that plays when my puppet is not possessed. So if I possess him, he'll stop doing it. If I unpossess him, he'll start waving again. So this is a pre-possession animation. So I'm going to show you how to do a pre-possession animation on a loop. So I'm going to show you how to do that. Now, if I possess him, I'll walk about and do all sorts of things and jump and climb on boxes and all sorts of things. But if I stand around for a bit, he gets bored. He starts tapping his foot and looking at his watch. And if I was to move off, he'll stop doing that. He'll only do that if I wait around for a certain length of time and don't do anything. There we go. He'll go into his idle animation. So I'll show you how to do an idle animation using our movement sensor. Right, let's have a look at his microchip. Up we go. Right. So I've got two microchips. One is the unpossessed waving, and this one is our idle animation. Let's do the unpossessed waving first. So I've got a link from possessed into our microchip. Let's open it up. I've put a node down so that I can see it inside the microchip nice and easy. So I put a node down that's linked to that possessed. I've called it possessed so that I know, so I can link from it from inside here. So I've not got lots of wires coming out of, I've only got one going into this microchip. That's always a good idea. If you're going to have various objects, gadgets that are using an external gadget multiple times, then put a node in so you've only got one wire going into your microchip rather than lots of wires going into your microchip. That's always better. Put it into one node and then pop it in here. Right, so we've got our possessed node, and I'm saying when not possessed, then I'm going to turn this counter on, and this counter is going to turn on this timeline. This timeline is on a loop, and here are my keyframes of his arms waving around. There we go. Make sure that your endpoint is inside the last of that keyframe. That way it will loop a lot smoother than if it just stops and starts. So try and get a loop going. So there's our wave, and when he is possessed, that wires into the reset of the counter, so it turns that all that animation off. So this is only running when he's not possessed. There we go. So that's a nice simple little program. When not possessed, turn on our animation. When possessed, turn off our animation. There we go. Right, this is our idle animation. This is only going to be turned on. This microchip is only going to work if the player is possessed. So I've linked that to the power. And we've got two wires coming out of our controller. So let's have a look and see what they are. Okay, first of all, we have our movement sensor. Our movement sensor, I'm looking at velocity overall. And I'm popping that into a calculator and seeing if it's 0. So does it equal 0? Which means we're not moving. If so, I'm going to set off a timer. This timer is set to 5 seconds. Let's just rewind that. There we go. Set to 5 seconds. And so after 5 seconds of non-movement, then it's going to set off our counter, which sets off our animation, which is exactly the same as we did with the waving. Now then, I was trying to get it set up so that it would turn itself off when you started moving using the movement sensor, but the actual animation itself provides some movement, so it was constantly turning the animation off, which is not what we want. So I changed it so that it was looking for not movement at 0, but movement under a certain number. But the problem with that is if your player moved really slowly, it would set off the animation. So what I've done, instead of using the movement sensor to turn off our animation, I have used the button presses. So in here, I've got a node, and I've linked that up to all of the buttons. There is no button on here for any button press, which is a bit of a disappointment. So you have to create this great big node with loads of wires. Never mind. So I've linked up all of the possible inputs that could happen from the controller into this node, apart from the motion sensor. I've left that alone. And I've linked that so that if you start pushing any button, so if you move the left stick or the right stick, or you jump or you fire or anything, you are breaking the idle animation. So you're resetting that timer and we're resetting that counter. That's all that's doing. That same node is just resetting this program so that it no longer plays the animation. And that is it. That's our idle animation program. There are other ways of doing it, obviously. You could use the input method rather than the movement sensor, but I think this is quite neat and works quite well. So there you go. How to do an idle animation and a prepossession animation. Hope that was useful. Thanks for watching, and I'll catch you in your dreams.